Welcome back to day 2 of Math Up with Dr. Mary. Today we're doing Unit 5, Session 2, Multiplying Fractions by Whole Numbers. Let's get ready. Get out your math journal, whiteboard, or blank paper, a student math book, and a pen or a pencil. So just to let you know that some of you worried a little bit yesterday about the questions in the slide, don't worry about those questions in the video. We are not grading you, and I'm still trying to figure out how to use them. So I want to start with some kudos and shout outs. This lesson is all about shouting out to the people and the different strategies that they used. But one special shout out is going to go to Zoe. I could hear her in her video reading the instructions and saying, oh, this problem's asking me to draw a picture, and then it's asking me to use numbers. I have to do both. Good job, Zoe, for reading the directions. Today is going to be brought to you by the word justification. If you are in Dr. Mary's class and you are rolling your eyes, I see you through the internet. Justification is a word that I use all the time in my classroom, and really it just means proving why the math works using mathematical meanings. So the questions to consider are the same as the questions yesterday. The first one was, how does the meaning of multiplication extend to fractions, and what stays the same and what changes when we multiply a fraction by a whole number? The second question was, how can we use the meaning of multiplication to solve problems with fractions? Some questions to consider. The second question is the one I really want to focus on today. How can we use the meaning of multiplication to solve problems with fractions? So as a reminder, the meaning of multiplication, one factor represents the number of groups, and the second factor represents the number in a group. And the problem, as a reminder, was Dr. Mary had 4 ice cream sandwiches. Her children, not Dr. Mary, ate 2/3 of the ice cream sandwiches. How much did they eat? So let's go ahead and look at a strategy brought to you by Zoe and Indu. Zoe and Indu drew out the 4 sandwiches and then thought about how to get 2/3 of 4, and they found that tricky. Some of you found that tricky yesterday. So they said, well, what if I just do 2/3 of 3? Well, that would be 1 sandwich each, because 1/3 of 3 is 1 sandwich. And here's another 1/3 of 3 is 1 sandwich, and 1/3 of 3 is 1 sandwich. Well, now what am I going to do with this extra 4th sandwich? So they then realized, well, what if I go ahead and break that 4th sandwich into thirds and give a 1/3 part to each of these groups? And so what they found was they had 1 1/3 sandwiches in 1/3 of a group of the 4, and in each other third. So then they went ahead and said, let's look at what 2/3 of the sandwiches would be. 2 sandwiches and 2/3 of a sandwich. So did they justify? They were thinking of 2/3 of a group of 4. What would be the number of groups in this situation? If you said 2/3, you're correct. 2/3 is the number of groups, which is kind of funny because really we're used to being a number of groups as being an amount that's more than 1. And in this situation, 4 is the number in a group. So a way that you can change your language to make it make sense is we're really saying it's 2/3 of a group of 4. So we're considering one group with 4 in it, but we're just figuring out 2/3 of that group of 4. Sal, Kendall, and Uma did it a little bit differently. They took the 4 ice cream bars and thought of them as being squished together in one big long bar. So that's 4 ice cream bars. And then they divided that one long bar into 3 parts. And then they thought, okay, so how many is in each 3 parts? Sal thought about it by first saying, I know it's at least 1. So you put 1 in each box. And then I know what's left over can be divided into thirds. So he put a third in each box. And then he knew that he had to think about what is 2/3 of the 4 ice cream bars. And so he just added 2 of the boxes together to make 2 and 2/3. Some people used numbers, and some of those numbers, the question is, how do they match what's going on with the multiplication, the meaning of multiplication? So Cassidy said 4 divided by 3 is the same as 1 1/3. And then she said, so 1 1/3 times 2 is the same as 2 2/3. Does that match Sal, Kendall, and Uma's strategy? Can you find the 4 divided by 3 in the strategy? And can you find the 1/3, 1 1/3 times 2 in the strategy? Seamus and Will N, they thought about it as 1/3 of a group of 4 is 1 1/3. So 2/3 of a group of 4 is 2 2/3. Does that match Sal and Kendall and Uma's strategy? So the question I have is, which of these equations match Sal, Kendall, and Uma's strategy? Or do they both? If you said both of those equations can match the strategy, you were correct. Let's look at McLean's thinking. Actually, this is not just McLean's thinking. This is a shout out to many, many of you. McLean, Ava, Anna, Taylor, Indu, Ivy, Ruby, and Rowan all thought about the problem as 4 different sandwiches, but let's find 2/3 of each sandwich. And so you can see the 4 sandwiches here, 1, 2, 3, 4, and he found 2/3 of each sandwich. And then he added all those 2/3 together to get 8/3, or 2 2/3. So what about the number of groups and the number in a group in this problem? It seems a little bit different than the way the other kids were thinking about it. So was McLean, Ava, Uma, Taylor, Indu, Ivy, Ruby, and Rowan thinking about 2/3 of a group of 4? Or were they thinking about 4 groups of 2/3? If you said 4 groups of 2/3, you are absolutely correct. So I want to look at one other strategy here. This is a shout out to Athena, and I think maybe one other person might have used this strategy. This is the array model. So Athena started with the 1 group of 4 sandwiches, but then she said, well, I know my 1 factor of 1 is not actually 1. It's 2/3 of a group of 4 sandwiches. So I have to change this dimension to 2/3. And in order to do that, I really need to break this array into thirds so that I can see where the 2/3 are. And then she saw a 2/3 chunk in each one of these boxes to make 8/3, or 2 2/3. If you're not ready to use that strategy, that's okay. My question is, what do you think? Do you think that Athena's strategy matches more Sal, Kendall, and Uma? More McLean, Ava, Anna, Taylor, Indu, Ivy, Ruby, and Rowan's? Or more Zoe and Indu's? I have Indu in 2 places. Oops. Some people use some numbers. And here's the thing I want to tell you about numbers. It's fine to use procedures, but you have to know how it connects to the meaning of multiplication and why it works. And in some cases, some of you forgot to draw a picture, so you couldn't really prove how that matched up with the meaning of multiplication and how it matched up with the story problem. So for example, a lot of you wrote 4/1 times 2/3 equals 8/3 because 4 times 2 is 8, and 1 times 3 is 3. That is a strategy. It seems to work. We're going to look at that strategy later. But how does it connect to the meanings of multiplication is what I'm going to ask. And what about this strategy? 2/3 of a group of 4 equals 8/3, some people just said, well, I can just multiply the 2 times the 4, and that makes 8/3. If you just say that, you haven't justified your thinking yet. Why does that work? So I like to think about that as this 2/3 is a unit. So I can multiply it by 4 because I'm really multiplying the whole 2/3 4 times. Vic and Cameron had a whole different strategy with numbers. Vic and Cameron said 4 is the same as 12/3, which is the same as 4/3 plus 4/3 plus 4/3. And 4/3 is the same as 1/3 of 12/3. So they went ahead and just took 2 4/3, added them together to get 8/3. Vic and Cameron, your next step is to think about how that matches the meaning of multiplication. You did it pretty well because they told us right here that 4 is the same as 12/3. And so I'm adding these 3 together. You might just go back and label the parts of your problem and how they match the story. So what does 4/3 mean in the ice cream sandwich story? What does 8/3 mean in the ice cream sandwich story? All right, ladies and gentlemen, your challenge today. You're going to do a little bit more work on some different problems today. And this public record, I have linked for you in the assignment so that you can actually save it on your iPad and have it to refer to, have it so that you can look at some of the different strategies that you might want to use when you solve problems today. Today, your goal is to think about, how do I justify, how do I know that this matches the meaning of multiplication? And how do I know that my answer works mathematically? That is your challenge today. Have a wonderful day.